frequencies on the screen, and then we'll do everything we did tomorrow, today, again. And more of a, from beginning to end,
The whole process.
methodical step versus, okay, today I made sure everything was functioning, we got some things loaded, we did a little bit of training of what you would do to load the chemistry, then we went right to the process. We missed all the middle steps. We'll cover that tomorrow.
So this part will have a deposit, but the other side is empty. Can we use it?
We can use anything you want.
Okay.
It's what was on here?
You know what deposit on this one? What deposit on this one?
What is that?
What's the material?
What is it?
Is V2 of vanadium dioxide, not vanadium dioxide, some sort of vanadium oxide.
Okay, can you wipe this off? I don't know what it is. It's like a grease or an oil or an adhesive.
Watch it. It's
IPA, acetone, something like that.
yeah, isotone.
So,
Let me
thank you
ask
very much. So we need to clean it off, yes?
Yeah, there's something on here, but I can smear it.
definitely.
I don't want it to get on the heater.
Yeah.
Yeah, this is basically a junk wafer. We'll put something on there.
Wash this with acetone.
Yeah, there's something there. I don't know what it is.
What are these wafers made out of? What kind of material is the wafer made out of?
Yeah, this looks like two-sided silicon wafer. So you can see how the first part of it,
So far, so good. Okay. The export is important.
and then it's coming down to the small. That's normal for conditioning. Now that that's conditioned, we can take it off, put it back on if we want. Do you know offhand how many grams that is?
Yeah, it's
How
for
many
now,
grams
it's a
of what?
14-day license.
How many grams of TMA was ordered?
Then I'm gonna do like some touch-ups and maintenance.
I believe
Proper
25.
license for
Okay.
this.
I
You
believe
know
25.
what computer previously had Magix on it? Was it that one in the back there?
So ALD is a subset of CVD. So chemical vapor deposition,
ALD is a subcategory of chemical vapor deposition, not
Yeah.
physical vapor deposition.
yes. It's because CVD reaction, you have an oven and you're putting two precursors together at the same time to have a build. Okay, so you're building with the two precursors at the same time. So that's CVD. An ALD, it's using one precursor, letting it react to the points, clearing that out, putting the other precursor in, letting it react to the points. That's what makes it self-limiting. Once there's no more points, then the rest of it just gets wasted. And then you repeat. So you can do an AB process like that, or you can do an ABCD process if you have different chemistry. Physical vapor deposition, in regards to this, you have a target. You have RF on there too, or just DC? That's RF and DC. You have two guns in here, at least two. So, you have a target, and you have a difference of potential. Then you have a gas. The gas lights the plasma. That creates ions.
Ionized.
Yes.
Gonna ionize the.
Now it's charged. So you have a negative pole and you charge the ion. And what that does is it pounds and it just
On the
bombards.
target.
Yeah. So you have little bits
Release
of
the-
particles, and that's the sputtering part of it.
Okay.
Create the ion. You have the polarity difference. It pounds onto the target. The target deposits material in very small parts, and then you get the deposition like that.
Yeah.
That's sputtering.
As a sputtering, and so physical vapor deposition, even thermal evaporator is rather than having that attack from iron, charged iron to the target, we hit it off.
Yeah. So with PVD, PVD is a very directional process. So if you have the gun and you have the plasma, depending on the angle of the ions coming in, depends on how it sputters out. But for the most part, it's going to be line of sight. ALD doesn't work like that. You could have line of sight. It's going to sputter this way. You ain't going to get any deposition under here. You get in a, depending on how far the angle of the ion is coming into the gun, depends on how far the particulate's going to shoot out the other way.
Yeah.
So you'll see a pattern where it'll be above the gun. With ALD, it isn't like that. You can have, 250 micron and 10 micron have this little dinky trench, and the molecule is going to find its way in there, and it's going to react to the other point, and then it's going to release. So you can have a film that's conformal that'll be same here, down, up, and around. Versus if you had a grate on a PVD and you're sputtering it, that opening is going to get clogged. You're not going to get deposition up in there. So that's one of the advantages of ALD versus PVD. You can do a conformal coating on a three-dimensional object in ALD. You can't do it in PVD as well. It won't be conformal. But that is a lot faster. You can do an aluminum oxide target on RF in 20 minutes. It's going to take you 4 hours to do it here.
So, with what you say, with what you're saying, doesn't matter, the surface of your sample is quite flat, even with having some roughness, so ALD is possible to cover properly.
You could do a slight roughness, either one will do that. Now you can have, if you have greater power, you can have your rate increase on PVD. That will cause a different grain structure on your substrate, depending on how much material is thrown up in it. You will not have that structure in ALD. Since it is self-limiting, it's essentially pinhole free after the nucleation. So after the nucleation, you have a couple holes in the bottom of the substrate, but after the nucleation, it's pinhole free. It's a perfect aluminum oxide layer, where in PVD, you're going to have holes. So sometimes maybe your resistivity or your breakdown on your coating really matters. You can have a thin coating, but it got to be pinhole free. Maybe if you like really thin coating, a couple of nanometers, 20 nanometers, something like that, you can do it at ALD. You don't have to do it in PVD. But if you have thickness matters, then maybe PVD is better than ALD. So the advantage on ALD, you can do three-dimensional items or components conformally with a pinhole-free coating. You can't guarantee that in the PVD. But the PVD is a lot faster. If you just need, if you're just building a capacitor, especially since you got RF DC, you can do it oxide metal. And you can build a capacitor real fast in that.
So how about the range of materials for the positive? The range of materials you can use, so you can do.
Materials aren't compatible. Because this uses vapor. That uses a solid. Now you can use a solid. You can use solids in ALD with ovens. Certain solids you can use in ovens. If you get it to a point where you heat it, it'll become a vapor. It's solid at ambient. But if you heat it up to, let's say, 150 degrees C, if it comes to a state where you can get some sort of vapor pressure, whether via vaporizing, melting it, or subliming it. You could do that in an oven in a special vessel called a bubble or a flow tube. So it can be done in ALD, but that's special chemistry, special circumstances. You can't just take a sputtering target and cut it up and use it on ALD. Just won't do that. So that was the 50 cycles. Recipe's ended. So now, the ampoules have been conditioned. This is what we're using? Is this a new one?
Yeah, it's one side we use. This is just
Yeah, one side is
acetone.
new.
Wipe that off, please. Get a wipe scoop. Acetone or water?
Actually, acetone.
I just need a lot.
Pour us over to check.
Oh, there's something? Maybe from the atmosphere? No, that's a fingerprint. Okay. We'll just wipe it. So, now, the TMA's open. The water we can open. We're ready. If your normal process, you shut down, you're going to close those, shut the pump off, shut the flow off, shut the heat off. Then you start that up, wait the 2 hours, load the sample, and then you can open the valves and run the process. That's probably how you're going to normally be running it. You have any light? Just a tech light. You got a tech light?
Still recording. If it doesn't work, then I guess there's homework.
I just need a white. No whites at all? No, we'll just go with
Yeah, there's a lot of because the layer resolution is not 40 microns. I mean,
It's just the lamp form.